forward biased. So if the diode is forward biased, then we're going to have, if it's attached to a power supply, we're going to have current that's going to flow. So we can think as forward bias as equaling on. In a circuit, if I have all of my conditions are to be on and the diode is in forward bias, and it will conduct. If it does not, then it more than likely is burnt out, but it could be reverse bias. And reverse bias, for this theory, we're thinking that, well, reverse bias basically means if it's hooked up in reverse, it's going to be off. It's not going to work. So we can see on our power supply over here, we've got a small line indicating negative and the longer line indicating a positive. And unlike resistors, diodes are polarity sensitive in that you have to have them hooked up correctly. So you have to have it forward bias. Your biasing has to be correct. So in doing so, you have on one side, you have the anode, and the anode is positive. And then on the other side, you have a negative, and that negative is called a cathode. So the negative cathode and the anode positive. The negative cathode, this portion from here over, we're going to call this material that it's made from, this diode, we're going to call it N-type. So we're on the cathode negative N-type negative side, and then on the other side, on the anode side, well, it's got to be positive side, and we're going to call that P-type. P-type. So N-type and P-type material refer to how the diode has been doped, chemically doped, to either accept an additional electron, making it N-type, or to have holes or spaces for electrons to go, making it P-type or positive. In our circuit here, we're going to have current flow, and we're going to use electron flow theory, which says that we go from negative to positive. When I have a negative here and it's connected to my cathode here, these electrons are going to move in this direction. And in my N-type material in here, these electrons, these atoms, have an excess of electrons. So I might have 1, 2, 3, 4, and that one will be bound with that one, and so on and so forth. But maybe my N-type, I have an additional electron. So that's going to wanna sort of wander, meander in this direction as the other electrons are coming through here and applying force. This one's going to want to wander over, and this line right here that we're looking at here, this is called the P-N junction. So P-type, N-type, this is a junction point. This is where they meet. So this side, the P-type, we said, has an excess of holes for electrons to go to. So this electron's going to go over there. It's going to see a spot to go, and maybe this one here is being forced to go to over this one, and over here, all these electrons being forced, and back to source. Back to source. So that's what happens when it's forward biased. Now if we look at what happens when it's reverse biased, we will have So we'll change our polarity here. So I'm going to put a positive over here. And move this one over here. So I got a negative here, positive here. Okay, so the positive now on the cathode side here of the PN junction, and the negative over here on the anode P-type junction. So the negative on the power supply, P-type has got an excess of holes. And the electrons are going to be attracted to, and the atoms with the additional holes are going to be attracted to the negative. So there's going to be an attraction, a force of attraction here in this direction. And I've got a positive over here, and in my N-type material I have an excess of electrons here, an excess of electrons. So this is no longer going this way. This is going to have an attraction force going in this direction. This electron here is going to be attracted more towards this positive potential here. So what you end up having in reverse bias is these atoms and these electrons, they start moving in this direction. And these ones move in this direction. So what that leaves is, well, it leaves this sort of this region in the middle here. This region here kind of gets depleted, doesn't it? Because everything's getting squished to the one side. So this kind of is getting depleted. And on this side here, it's the same thing. This is getting depleted as well because it's being attracted in the other direction. And I say depleted because this area here is actually called the depletion zone. So from, say let's move a line over here, here, and another one over here. So now this region here has been depleted. And that is called the depletion zone. N-type material that is being attracted to the positive, a P-type is being attracted to the negative, creating this increase in this depletion zone. Now, if you were to reverse bias something and get the current to flow, that would be called reverse breakdown voltage. And reverse breakdown voltage says that, well, if I continue to apply pressure to this diode, eventually I'll be able to get current to flow. And at that point, at that peak inverse voltage, when current starts to flow, there will be an unlimited amount of current flowing. And that unlimited amount of current is called avalanche current. So if you think about an avalanche, there's nothing much to stop it. So once it starts to conduct in reverse bias, it will cause a breakdown and you'll get avalanche current, which will destroy the diode.